A very good morning to all my dear students. I welcome you all to the third class of the online session 2020-2021. Today I am going to start and discuss the next topics of the chapter. Yesterday we had recapitulated lots of numericals, isn't it, which was, probably it was explained to you all earlier also based on speed. Today I am going to discuss about the next topic, that is uniform and non-uniform motion, and this is very important. What is uniform motion and what is non-uniform motion? Before that, I would like to tell you one thing, that if I want to graphically, I want to represent the speed. If I want to represent the speed graphically, how should I draw it? What should I do? I should draw a graph having time in the x-axis, and I can draw a graph having distance in the y-axis. Supposing your time is given in second and your distance is given in meter, and there is a slope. This slope represents the speed. This will give you the speed. So for a distance time graph, the slope represents the speed of the vehicle. Okay? So before this, let me tell you what is uniform motion. What is a uniform motion? Uniform motion is a motion in which a body covers equal distance in equal intervals of time. What is a uniform motion? Repeat it with me. Uniform motion is a motion in which a body covers equal distance in equal intervals of time, and the speed of the vehicle or the body throughout the journey remains constant, means same. The speed of the body throughout the journey remains same or constant. Alright? Now with the help of an example also I am going to show you, okay, the meaning of uniform motion. Next comes to non-uniform motion. Non-uniform motion. What is a non-uniform motion? A body covers unequal distance. What does it cover? Unequal distance in equal intervals of time. The distance covered by the vehicle is not the same throughout the journey. I mean, the distance will keep on changing at a different rate. Understood? So it covers unequal distance in equal intervals of time. A body covers unequal distance in equal intervals of time. For a distance time graph for a non-uniform motion will never be a straight line. If you see for a uniform motion, the distance time graph will always be a straight line. Got it? The distance time graph will somewhat be like this. But for a non-uniform motion, it is going to be a curve. It will not be a straight line because the distance is covered unequal. A body covers unequal distance in equal intervals of time. Is that okay, children? Next, I was talking about the speed. As I told you, for uniform motion, the speed of the body remains same throughout the journey. But when you come to non-uniform motion, the speed of the body does not remain same throughout the journey. The speed of the body keeps on changing. So when we come to this thing, non-uniform motion, instead of finding out the speed, we are going to calculate the average speed of the whole journey. In this case, we can talk about the speed, but in case of non-uniform motion, we are going to talk about the average speed of the vehicle. Is it okay? Now with the help of an example, I am going to show you the difference between uniform motion and non-uniform motion. Okay? And we are also going to draw the graph also. So for that, let me take up an example from the book itself. Let me solve an example from the book itself. Okay? So I hope all of you are having your book with you. If you have your book with you, we can solve this numerical which is given on page 224. Numerical which is given on page 224. Okay. Question number we can do 48. Okay, before 48, let us solve question number 47. Page 224, question number 47. So what does this question number 47 tells us? The distance travelled by a car at various time intervals are as follows. Distance is given in meter. I hope all of you can see. It is like this. So I am going to represent it in the form of a table. One side distance, another side time. Time is given in second. Alright. Distance, one side, another side, time. In a tabular form, I am going to represent this question. Distance 0. Okay. Then 5, 10, 15, 20 and 25. And what about the time? 0, 2, 4, 6, 8 and 10 seconds. You have to draw a distance time graph for the car. And what conclusion do you get from this graph about the nature of motion of the car? So these are the two questions they are asking us to solve in this particular numerical. Okay. So once I solve this numerical, your concept will get clear regarding the uniform motion. So look at this question once. Look at the distance. Can you see with time the distance covered by the vehicle is at the same rate? Means every time it is increasing by 5. 0 means the body is at rest. The body is not moving. It will start to move. So when something is not moving, obviously the distance covered is 0. It has not started moving, so time is 0. It is the initial. Now when it starts moving, after 2 seconds, if you note down the reading of the odometer, do you remember? Odometer is an instrument which shows you the distance covered by the vehicle in kilometer. So if you go through it, you will find it is covering, for example, 5 meter. After next 2 seconds, that means 4 seconds, it is covering 5 plus 5, 10 meter. After 2 more seconds, 6 seconds, 15 meter, 8 seconds, 20 meter, 10 seconds, finally 25 meter it covers. Okay. So this is how you can see the body covers equal distance in equal intervals of time. So from the data given to you, you can easily make out that this is a question of uniform motion. From here only you can make out this is a question of uniform motion. Is it clear? Isn't it? From the definition only, you can verify the definition. A body covers equal distance in equal intervals of time. Now this particular table, these data is given to me. I am going to draw a distance time graph with this data. Okay? Distance time graph with this data. So here, let me show you. This is the x-axis. This is the y-axis. X-axis you can show the time which is given in second. And y-axis you can show the distance which is given in meter. So if you are having a graph paper, you can solve it in the graph paper also, or if you don't have a graph paper, you can simply solve it on a piece of paper. Alright, any way you can solve it. Initial, this is 0. This point is 0. Then I am taking equal intervals. So what equal interval of time is already given? 0, 2, 4, 6, 8, 10. Got it? Look at the distance. Distance is also increasing at a constant rate. Due to lack of space, I am noting it down like this, okay? 15, 20, 25. Now you see. Distance I can take 5, 10, 15, 20, 25. Note one thing, that here whatever units you are taking, the gapping should be same. See, the time is increasing by 2 seconds, and in case of distance it is increasing by 5 seconds. 5 meter. Now let us plot the points given to us. When time is 0, distance covered is also 0. So this is the first point. When time is 2 seconds, distance covered is 5 seconds. Second point. When time is 4, distance covered is 10 seconds. 10 meter. When time is 6 seconds, distance covered is 15 meter. All of you can try it along with me. When time is 8 seconds, your distance covered is 20. And when time is 10 seconds, the final distance covered is 25 meter. Now I am going to join all these dots together. Let me join the dots and let me see what kind of a line am I getting. I am getting a straight line. And remember one thing, for uniform motion, your graph, distance time graph will always be a straight line. This is the first question given to you, that you have to plot the distance time graph, and this is what I have done. I have plotted the distance time graph. Is it okay? You are going to do it exactly the way I am showing it to you here on the board. Now, since it is a question of uniform motion, what conclusion can you draw? You can say that the body covers equal distance in equal intervals of time. So this is a motion. This motion is said to be uniform motion. This motion is said to be uniform motion, and it is a straight line. Another thing I will show you, which is not asked in the question, but for your information. Since it is a question of uniform motion, you can easily calculate the speed of the vehicle. Okay, let us find out the speed of the vehicle. Let me name the points. Supposing this is point A, this is B, C, D, E, F. Let us find out at any 2 points. Let us see what is the speed of the vehicle. Let me take, supposing, point C. So speed of the vehicle at point C is, speed is distance by time. So your distance covered at point C is this, 10 meter, and time is 4. So 10 by 4, that comes to 2.5 meter per second. Another point, let me take F. At point F, what is the distance, what is the speed of the vehicle at point F? Again, distance by time, distance is 25 divided by time, 10. Again, it is 2.5 meter per second. So what do you notice? Don't you find that the speed is same at every point? Whenever it is covering the same distance, the speed also remains the same throughout the journey. So this is a question of uniform motion. So wherever you find out the speed for uniform motion, speed will remain constant throughout the journey. So this is an example of uniform motion. A body covers equal distance in equal intervals of time. The distance time graph for uniform motion is a straight line. The speed throughout the journey remains the same or constant. At whichever point you calculate the speed, it will remain the same, distance by time. This is a question of uniform motion. Let me go to the next question regarding non-uniform motion. Let me see. For non-uniform motion, let us take up one question. Non-uniform motion. Let me see in the book if we have a question. Okay, let us do one thing. Let me only take up a question. Okay, let me only form a question to show you all what happens in case of non-uniform motion. Whether the definition I am giving you, that a body covers unequal distance in equal intervals of time. The distance time graph for non-uniform motion is never a straight line. Okay, let us see. Let us prove it whether it is really true or not. Now, this is distance, supposing in meter, and the time is given in second. Alright. So initially when the body is at rest, distance covered is 0, time is also 0. Supposing you are calculating after 2 seconds, you find the distance covered by the vehicle is 5 meter. After 4 seconds, the distance covered is 10 meter. After 6 seconds, distance covered is 5 meter. After 8 seconds, you find that the distance covered by the vehicle is, supposing, somewhat, it is supposing 2 meter, and after 10 seconds you find the distance covered is again 10 meter. Look at the figures that I have given you. You can easily make out from the figure that the distance is not increasing at a uniform rate. Sometimes it is covering 5, sometimes 5 plus 5, 10. 10 plus 5, it should have been 15, but it is not 15. It is again, it has decreased. It has covered less distance in 6 seconds. So this is not uniform. Distance is unequal. Let us plot the distance time graph for this particular question. Again, the same way, x-axis you can construct the time given in second. Y-axis you can simply denote the distance given in meter. 0, 2, 4, 6, 8, 10. We have to take equal intervals. So let me take supposing 5, 10, 15, 20, enough, because maximum is 10 over here. So 15, 20 is also not required. Now let me plot. When time is 0, distance is also 0. So this is the first point. When time is 2 seconds, distance covered is 5 seconds. When time is 4, distance covered is 10. When time is 6, distance covered is 5. When time is 8, distance covered is 2. Somewhere here 2. If you are taking 5, 0, 1, 2, 3, 4, 5, it's like this. So somewhere 2 is here. When time is 10 seconds, distance covered is also 10. Now let me join all the dots. Mind that when you are joining the dots, it should be exactly like this. Not whatever you want, you cannot just join. Okay, one by one. First was this, then this, then comes this one, then this, finally this. What do you find? Is it a straight line? It is not a straight line at all. So this is understood from the question that this is an example of non-uniform motion, and the graph will never be a straight line for non-uniform motion. Okay. Now again let us name the points, supposing A, B, C, D, E, F. Again, supposing at any two places, 2 points, I will calculate the speed and let me check whether the speed remains the same or not throughout the journey. Supposing again speed at point C, distance by time, speed is distance by time. What is the distance at point C? It is 10 meter and time is 4 seconds. So 10 by 4, that comes to 2.5 meter per second. Okay, let me calculate at this point E. Speed at point E, distance by time. Again, distance here is 2. When time is 8 seconds, distance is 2 meters. So 2 by 8, that is 1 by 4. 1 by 4 means 0.25 meter per second. Okay, this point we have calculated. Let us take another point, supposing speed at point D. Again, distance by time. Point D, 5. Time is 6. So 5 by 6. 5 by 6. So something around 0.8 meter per second approximately. Alright, what do you see? The speed of the journey is not the same at every point. Speed keeps on changing. And before only explaining, I told you for non-uniform motion, it is not possible for us to calculate the speed. You are going to find out the average speed. What is average speed? So, no need of finding out this. No need of finding out speed in case of your non-uniform motion, because you will not be able to tell the exact speed. What are you going to do? You are going to calculate the average speed. So, average speed is equals to total distance by total time. Please note down this formula. Average speed is total distance by total time. What is the total distance of the whole journey? Let us add up. 5 plus 10, 15 plus 5, 20, 20, 32. 32 meter. And the total time is already getting added. So total time is how much? It is 10 seconds. So my average speed is 32 by 10. That is 3.2 meter per second. You can talk about the average speed in case of non-uniform motion, mind it. Non-uniform motion, it is the average speed, not the speed, because the speed does not remain the same throughout the journey. Got it? So this is one example that I have given you. You can get this kind of question. So remember that for uniform motion, a body covers equal distance in equal intervals of time. In non-uniform motion, a body covers unequal distance in equal intervals of time. The distance time graph for uniform motion is a straight line. For non-uniform motion, it is not a straight line. Speed of the body for uniform motion remains the same throughout the journey. Speed does not remain the same. We can find out the average speed of the journey in case of non-uniform motion. Is it okay? One more thing I would like to discuss. Supposing I give you a graph like this. I give you a graph like this. Again, this is the time in the x-axis and this is your distance in the y-axis. And this is your graph. You can see I have drawn a straight line which is parallel to the time axis. Can you tell me what does this line, this graph tells us? What information do you get from this particular diagram? Yes, it means the body is not moving. Like if I sit right now, I am not moving, but time, you cannot stop time. Time will keep on moving, isn't it? So time is increasing, but your distance is not increasing. That means the body is stationary or is at rest. Body is at rest. Body is not moving. Got it? So this is the distance time graph, and there are lots of advantages you can get from a distance time graph. By graphically representing something, you can find out the speed at any interval of time. You can easily find out, you can see the distance, how the distance is changing. Okay, so these are certain advantages of a distance time graph. Got it? So this is all about today's class. So we have discussed about the topic uniform and non-uniform motion, which is a very important topic. Kindly practice certain numericals, solve the worksheets, alright, and study. So that's all for today. Then the next topic, time, I'll be discussing it in the next class. Till then, all of you study and have a good day. Thank you.